Welcome to in third unit, design of connecting rod. Now we will see that what is the design, what is the materials, and how to will design. We'll see that. So here, generally the connecting rod, the we are going to using for to transfer that energy from crankshaft to piston to crankshaft. This is a very important element in that IC engines. So generally this is consists of a long shank, very long shank. It will be consist, and then small end and big end bearings will be there. Generally the cross section of mm, the cross section of the connecting rod is I section, rectangular, circular, tubular, or H section. So, there are different sections. Now we will see that just given a small introduction. Now that we will see that what is that history of that connecting rod. So generally we are going to asking what is that connecting rod. Connecting rod connect the piston to that crankshaft in a reciprocating piston. What it will do to transmit that explosive force of the piston to the crankshaft and transmit that rotary force of the crankshaft to the piston and to compress that explosive level. So that is the thing. Another what is that history of this crankshaft is evidence for that connecting rod appears the late 3rd century Herpias sawmill in Roman Asia. That's Turkan people, means Turkey people, they are found out this connecting rod. It's also appears 6th century Benjamin era sawmills excavated emphasis and Asia Minor modern Turkey and Jersa Roman Syria. So the crank is the crank and connecting rod mechanism of these Roman era mills converted to that rotary motion into that water wheel into that linear motion. So that by the 16th century evidence of the cranks and connecting rods of the technological sides of the artwork, European people, they are again they redesigned. So this near about machines we are introduced in 1588. Along deficits 18 examples, a number of rises and other things he found out, address broker to the 45 different machines he applied this connecting rod mechanism. So today connecting rod is the best known through that use of internal combustion engines and piston engines such as automobile engines, where particularly if you are if it is connecting rod is not there, nothing will be there. In the even the steam boilers, means steam engines, railway engines, we are going to using connecting rods. So these are very distinctly different design from earlier forms of the connecting rod and steam engines and locomotives. So we can see that all the things. Now we will see that how that the difference between the previous and current. Earlier will be there, how you can see that in picture, how that connecting rod, sorry, will be there. Now that the connecting rod will be there. Other two pictures, so you can differentiate with this. And now I will see that what is that, how the connecting rod will be there. Construction of the connecting rod, bushing, connecting rod. See that bolts, that two bolts we are going to connecting big end bearing and small end bearings. And another one is upper bearing shell, and second one is that lower bearing shell, and bearing cap, nut, and all the things we can see that new connecting rod, these things. Now we will see that connecting rod constructions. See that clearly I am showing the picture how that constructions will be there. Connecting rod has a small end and big end bearings. So both I am going to showing over there. You can see there. and big end and has a inserts will be there, and small end may have a bush and gudgeon pin will be there, so that we can end that one. And there may be an oil hole in the small end, and here each rod and cap must be numbered for identification. For identification. Next, we can see that how that connecting rod and small end. We will see that the rod normally has crossed that selection of a circle or an oval for that low and medium speed engines. For the high speed engine, the rod has a section of I shape. There is a drilled hole along the rod to feed that lubricating oil and to reduce that weight of the connecting rod. Small end bearings will be there. The small end and the rod are normally forged in the one piece, and that small end is drilled hole to feed that lubricating oil for that cooling purposes and lubricating purposes. See that very clear I am showing. Sections also I showed over there. Generally this section will be there, I section will be there for that one. So I section will be there. In this connecting rod length will be depends upon the ratio of L by R, where R is the radius of the crank, and it may be noted that length of the L by R ratio will be decreased by L by R. So this increases angularity of the connecting rod, which increases the side thrust of the against of the cylinder liner, which is increases the wear of the liner. So here that big end bearing and small end bearing, so that thrusters will be there. So the small end of the connecting rod usually generally made of from an I shape. See that very clearly I am going to showing that small end is going to be I, and provided with that bush of prosperous bronze. Prosperous bronze will be there. It is connected to the piston by means of the piston pin or gudgeon pin. We seen that earlier class. Now that generally the connecting rod usually we are going to manufactured by drop forging. We are going to manufacturing by drop forging, and this drop forging process should have adequate strength. It will give that adequate strength, stiffness, and minimum weight it will give. The material generally we are going to using for connecting rod, mild cast iron steel having that 0.35 to 0.45% carbon, to alloy steels, chrome and nickel chrome molybdenum steels. The carbon steel is having 0.35%, so 0.35% will be there, and carbon has ultimate tensile strength will be there. So in these two cases will be we have to note it. Another one of the important point is when that heat is treated, the carbon steel with 0.45% carbon, and ultimate tensile strength is 750 megapascals. Ultimate strength is 75 megapascal. For high speed engines, in some cases assembling surface between two parts, big end and small end, makes with the center of the line connecting rod at an angle 30 and comma means 45, another one angle is 45 or 60 degrees. We can connect that rod angles. Yeah, so then it will permit that cutting force, and in cutting force. Generally V-shape engines, where different shapes of engines will be there. V-shape engines, the two similar connecting rod can be fitted, one of the crank rod and pin, while that auxiliary connecting rod for big end bearing and small end bearings. So these two will be there. Different V-type engines only I taken as one example. Here we can assemble that surface and parts, big end bearing and small end bearing. So what are the angle? 30 degrees, 45 degrees or 60 degrees at maximum for V type. I am going to clearly, I am going to showing that this center angle of two connecting rods, and it is going to be connected one big end bearing, but two small end bearings is going to be connected to one big end bearings. See that now this you see that casting of the connecting rod. Okay, in this small end and we can body sides we can manufacture and use it as speed engines, cap, pin, and with bodies only, and maximum it can withstand as 6500 rpm. Okay, whenever we are going to consider speed for that one, we can consider up to that one. Now we will see that see different parts of the bearing shells and parts of the connecting rod, small end bearings and oil hole where I did earlier I told, and small end eye, so expansion bolt, so two bolts we are going to fitting, and retaining lug, and one more thing, please but observe that big end bearing shoes and big end cap will be there, and connecting rod with bearing shells. So all these things we can see that what are the parts are there in that connecting rod, and construction when the connecting rod connected to a piston and crankshaft. See that piston will be there, crown will be there, piston pin will be there, skrit will be there, and crankshaft and big end bearing, how that connection is there to that crank pin. You can clearly we can observe that one. So here one more slide we can see that how that manufacture of the connecting rod. So materials used for connecting rods we discussed again one more time. So structure of the steel, aluminum and titanium. Steel rods are the mostly widely produced or used as connecting rods. Generally applications are the best used daily drivers, endurance, racing due to their high strength and longly. Okay, the only problem with using steel rods, that material extremely heavy and consumes more power and adds stress. So that in this work below mentioned, materials are taken as generally what are the materials we are going to taking. So carbon steels we are going to taking, high strength low alloy steels, corrosion resistant high strength low alloy steel, and quenched and tempered alloy steels we are going to taking, and corrosion resistant alloy steel and tempered alloy steels we are going to taking of this manufacturing of this connecting rod. So see that how that casting will be there, cast in sand. Okay, small little seam on the both sides we can put it, and use it we can speed motors. So maximum rpm already we discussed, this is 6500 rpm. So now we will see that forging, how we are going to forging of the connecting rods. See that heart shaped connecting rods, thick seam on the both sides. First of all we will take and use it as speed motors. Okay, bolt and nut assembly used it in inches at RPM range about 5500 RPM to 6800 RPM or further. We can use that one. So next we will see that one more forged billet rod machined from that solid piece of steel. No pertaining edge. Bolts are screwed to hold that cap on, and strongest connecting rods up to that 1200 horsepower engines we can use this one. Okay, and sintered connecting rod where we are going to, we can use up to that this type of connecting rods 7000 rpm, and each cap and each rod is unique with itself. Partling edge and where the cap and that rod meet fractured. And powdered metal also we can use that together and then put into an oven where sintered metal means of organizes together and forms of the rod. So all these things we can see that for this thing we can see that how that lubricating oil flow that connecting rods. So connecting rod consists generally connecting rod of the piston, it will encounter high dramatical loads from that rapid back and forth motion. The length of the rod between the two centers bearing cups is used for low friction rotation. An oil channel is drilled between the two centers. These channels can also have various configurations. Initially, the oil is pumped to maintain the general bearings. The crankshaft has dedicated holes. The engine oil flows through that crankshaft internal bore and reaches the big end and small bearing. From the big end and small bearing, it will reaches that connecting rod. So we can see that these are the connecting rod. And from this rod reaches the piston. From piston wall it reaches the cylinders. So that entire this is that lubrication process of the cylinder. You see that how that hydrodynamic non-contact bearings we are going to using, not grooved shell and grooved shell supply the hole. You please observe that. So the main bearing of that oil will be enter generally into the lubricating of the bearing. The rest of the enter will the crankshaft will be there. So the oil will be the circulated whenever that engine is running. Okay, thank you.